So we're going to start with effects of changing a dimension on the volume and surface area. So if a dimension of a solid is multiplied by a scale factor, we're going to call the scale factor A, then the surface area is going to be our scale factor squared times the original surface area. And the volume will be our scale factor cubed times the original volume. So in practice, if the dimensions of a figure are doubled, how many times larger will the surface area be? Well, if they're doubled, that's times 2. The surface area will be that squared, so it will be 4 times larger. So number 2, the surface area of the figure is 62 centimeters squared. If the dimensions are multiplied by 5, what will the surface area of the new figure be? Well, our scale factor here is 5, and surface area is squared, so I'm going to square our scale factor to get 25, and then I will take the original surface area, multiply it by 25 to get 1,550 centimeters squared will be the new surface area. So this works if all of the dimensions are being doubled and all of them are being multiplied by 5. So for volume, the dimensions of a figure are multiplied by 4. How many times larger will the volume be? Well, I take the scale factor 4. For volume, we cube, so it will be 64 times larger. And then in number 6, we have a volume. We're saying all of our dimensions are doubled. So if I double each dimension, that's 2. I cube it for a volume, which gives me 8 times larger. So I take 110.5 and multiply it by 8 to get 884 feet cubed will be the new volume. So again, these are if all of the dimensions are multiplied by the scale factor. If we only have one dimension that is multiplied by a scale factor, then we do not have similar figures. So we cannot multiply by these properties. In this situation, we're going to choose test values and then compare our answers. So, as a number 9, how many times larger is the volume of a cylinder if just the height is doubled? So if I take our original cylinder and I say, okay, I'm going to pretend that the radius is equal to 1 and that the height is equal to 1. So I'm going to find the volume, which is pi r squared h, which will just give me 1 pi. So that's going to be my original. And then here is where I'm going to double my height. So I'm going to keep my radius the same, and then my height will now be 2. So the volume here, I'll get pi r squared h, and this will give me 2 pi. Well, I compare 2 to 1, and I get 2 times larger. So number 10, I'm looking at volume, and then I'm saying the square pyramid of the base edge is tripled. So for volume of a pyramid, we can remind ourselves of that formula, but it is 1/3 area of the base times the height. So here I'm going to say the side of my square pyramid is equal to 1, and the height of my pyramid is 1. So my volume is going to be 1/3. The area of the base is 1 squared times the height. Well, this will give me 1/3. In my second situation, it says the base edge is tripled, so that means the side will be 3 and the height will remain 1. So here my volume is going to be 1/3 times 3 squared times 1. This will give me 3. So then if I say 3 over 1/3, which is again here I did 2 over 1, gave me 2. 3 over 1/3 will give me 9 times larger. I'm making this ratio just to compare, but you could compare just visually 1/3 to 3 and see that that is 9 times.